University of Melbourne scientists have contributed to the discovery of a particle similar to the elusive Higgs Boson, which could explain the origin of mass and the beginnings of the universe. The discovery was announced via satellite from CERN Switzerland, home of the giant underground Large Hadron Collider, in a two-way link to the 36th International Conference on High Energy Physics at the Melbourne Convention Centre. The conference, held for the first time in Australia, was hosted by the University of Melbourne and the ARC Centre for Particle Physics under the leadership of Professor Geoffrey Taylor. It was much anticipated that the existence of the Higgs particle, discovered after thousands of experiments at the Large Hadron Collider, would be announced, and scientists weren't disappointed.
The Higgs boson is really critical component in the standard model to give particles a mass. And so what's so fantastic about this discovery is that after this long time, we've finally found the Higgs boson, and this suggests that now we essentially understand how elementary particles obtain a mass. However, this is just the tip of the iceberg of this discovery, because we know that the Higgs boson will probably open the door for other possible discoveries, because the next thing that we have to do is to understand its properties. And by understanding its properties, it'll tell us about even other exotic ideas. And so these are exotic ideas like extra dimensions of space, supersymmetry.
The university has had a long-held relationship with CERN. For the past 20 years, Melbourne scientists have contributed to the Large Hadron Collider and its development.
This is the result of work over many years by many thousands of people, and we're very proud to be part of it, and we'll try and continue to be part of international research. I think it's very good for Australia to be hooked right into these kinds of big projects as partners. We have great students, we have great staff, so we're doing our job, and for the university it's a great role too, because we have very good projects, and working with people from all over the world is a very unique opportunity.
It's a big collaboration effort. The collaboration, Atlas and CMS, were founded in 1992, and since then we really built all these experiments. We needed to prepare all the software and all the analysis. So it's really a collaboration from 150 institutes from many countries.
This feat, that has brought us from 50 years ago making the prediction to being able to build apparatus that can measure it and techniques to measure it is an amazing thing, and human beings should look back on this, and I know that history books will look back at this as a big major step that not only brought us new information about our universe, but a new way of thinking about our universe, and that's a very important step for mankind. We know we have a particle, we know it's a boson, but it sure smells like a Higgs and tastes like a Higgs. I'm pretty sure that's what we'll confirm in the next year or so.
During his visit to Melbourne, the Director General of CERN, Professor Rolf Hoyer, was awarded an Honorary Doctorate by the University of Melbourne for his contribution to science.
I feel very honoured, and I take it not only for me, but as I said, also for the relations between the university and CERN, or the university and the Large Hardron Collider project and the Centre of Excellence. So I take it for everybody. This is a basic question of the beginning of the universe. I think maybe we are at the moment decoding the DNA of the universe. And that's important, isn't it? And it's fascinating.